For this build with Vapi challenge, we build a AI tutor, but not just a normal AI tutor. It is a fully interactive AI tutor that has control to its own 2D canvas. So it can write, draw stuff on the board while teaching, giving a feel like a real teacher would do. So yeah, here's a small demo.
Hi there, how are you doing? I am your tutor for this session. Let me know when you are ready to start.
Hi, I'm great. I think we can start now.
Let's start with the introduction to Newton's laws. Newton's laws of motion are the foundation of how we understand movement, whether it's a soccer ball rolling across the field or planets orbiting the sun. These laws describe the relationship between an object, its motion, and the forces acting upon it. They're so fundamental that they help explain both everyday events and astonishing astronomical phenomena. Sir Isaac Newton formulated these laws in the late 17th century, which truly revolutionized science and our view of the universe. You can see a summary and key points about this on the whiteboard. Any questions about this introduction?
No, it's all clear.
Moving on to the first law, inertia. Newton's first law, also called the law of inertia, tells us that things don't just start or stop moving on their own. If something is at rest, it wants to stay at rest. If it's moving, it wants to keep moving at the same speed and in the same direction, unless something else, an external force, makes a change. For example, a book on a table will just sit there unless you push it. If you roll a ball, it keeps moving until friction or another force, like hitting a wall, slows it down or stops it. The more massive an object is, the more inertia it has, which means it's harder to change its motion. You can see the definition, an example, and a note about inertia on the whiteboard. Any questions about this topic?
Oh, is this the reason we need a seatbelt in the car?
Great question. Yes, exactly. That's a perfect real-life application of Newton's first law, the law of inertia. When a car stops suddenly, your body wants to keep moving forward at the same speed the car was going. If you're not wearing a seatbelt, there's nothing to provide that external force to stop you, so you can keep moving forward and get hurt. The seatbelt acts as the external force that changes your motion, keeping you safely in your
I
seat.
understood.
Would you like to? Great. Now, moving on to the second law, force and acceleration. Newton's second law connects force, mass, and acceleration. Says that the acceleration an object experiences depends on two things: how much force you apply and how heavy or massive the object is. The famous formula that comes from this law is F equal mxa, where F is force measured in newtons, m is mass in kilograms, and a is acceleration in meters per second squared. So if you push a lighter cart and a heavier cart with the same amount of force, the lighter cart will speed up much more than the heavier one. This is why it's much harder to push a loaded shopping cart compared to an empty one. The more mass, the less acceleration for the same force. You can see the formula and an example on the whiteboard. Any questions about this topic?
No, all clear.
Now let's explore, now let's explore the third law, action and reaction. Newton's third law says that for every action, there's an equal and opposite reaction. This means forces always come in pairs. If you push on something, it pushes back on you just as hard, but in the opposite direction. For example, when you jump off a boat, you move forward, but the boat moves backward with the same force. This is also why rockets launch. The engines push exhaust gases down, and the rocket is pushed up in response. You can see this idea summarized along with an example on the whiteboard. Any questions about this topic?
No, perfectly clear.
Great. Now let's finish with a summary and some real-world applications. Newton's three laws explain almost all the motion we see every day. Whether it's a car crash, a soccer ball being kicked, or a rocket blasting into space, these laws help us understand what's happening by looking at the objects, the forces, and how they interact. For example, seatbelts in cars, bridge engineering, and even how we walk or play sports. All of these can be explained using Newton's laws. You can always use these laws to predict or explain motion by identifying the forces involved. Check out the summary and examples on the whiteboard for a quick review. Any questions about how these laws apply to real life or anything else we've covered?
No, everything's clear.
Great job. We've covered all the key concepts about Newton's laws of motion. You now understand how Newton's three laws explain movement and forces in everyday life, from why seatbelts keep us safe to how rockets launch, and even why it's harder to push heavy objects. Thank you for being such an engaged student, and keep up the excellent learning. Do you have any final questions, or would you like me to end our session here?
I think we can end the session.
Goodbye.
Yeah, so this was our demo for this hackathon. This is the whole notes the AI made while teaching. So here are some of the future plans we have for the project. One is to generate on-spot images or flowcharts, so it would be easier to explain concepts. Second is to make the board collaborative, so user can write his or her thoughts. User can solve problems and make the whole experience much more interactive. Another one is like we realized this architecture, voice LLM controlling a 2D canvas can have some other application as well. For example, you can create a thought organizer application where you can just talk to the agent and tell everything you are thinking, and it will create a beautiful 2D mind maps, etc. So yeah, we are looking forward to it. Thank you.